Welcome on my channel. Today I want to describe scientific notations and conversion of simple number to scientific notation and scientific notation to simple number. Numbers can be really big or really very small. Not only really big or small, involve many zeros. It's hard to quickly compare and it's not easy to tell how many zeros are in the big or small number. Scientific notation help it out. It uses using a long sequence digit to represent a number. Scientific notation has used a shorter number multiplied by power 10. In the form we write as these places for some number and this is for some exponent. For example, we take a number that number we take here 196 million. Here equivalent number in scientific notation is 1.96 multiplied by 10 raised to power 8. Let us convert this number into scientific notation. We know that decimal point is always on the rightmost of the original number. This is decimal point. When we shift decimal to the one number left means in fact we write copy here again and shift decimal to one number to the left. So it becomes 196 such like that. And we write it as multiplied by 10. We again shift decimal to the left. And we observe that this number becomes 10 multiplied by 10 because when we shift one number we multiplied 1 10 and when we multiplied two numbers, numbers, we have two tens. We again shift decimal to left and observe that new number is 10 times smaller than old number. And if we repeat this process, we observe that it is very hard to check zero all time. We write here shifting decimal to the left and multiplied 10 at each step. And next we have Next we have 1 2 3 4 5 6. We have 6 tens here. We observe that this part involve number getting shorter. This number become small, and this part which we tell us compensate getting longer. This is a big problem, that if we short this side, then the other side is become longer and very difficult to write. This problem can be fixed by exponent. We can write 10 multiplied by 10. We can write 10 multiplied by 10 is equal to 10 raised to the power 2, and 10 into 10 into 10 is equal to 10 raised to the power 3. 3 is exponent. That's much better. Now we continue the process and shift decimal point, but this time we write exponent bigger than previous instead of 10. We write it again. 19600 multiplied by 10 raised to the power 4, similar to similarly 196 multiplied by 10 raised to the power 6. We will stop when we have only one digits remaining on the left, one non-zero digit. So we have 1.96 multiplied by 10 raised to the power 8. We observe that all these lines, we write again the all lines. 196 10 raised to the power 4, 196 0 10 raised to the power 5, 196 multiplied by 10 raised to the power 6, and 1.96 multiplied by 10 raised to the power 8. So we observe that all these lines are exactly the same value of the first one. These all are equal to, just like first line, this is original number, and the last line is scientific notation. Here we have a question that why the only last line is scientific notation and not the others. This is scientific notation and the other lines are not scientific notations. The answer is, for number division, it's supposed to have only one non-zero digit to the left, just like that. of the decimal number. In our example, 1.96 is smallest multiplied by 10 power 8 is equal to original number. So the scientific notation is the way to write a really big number reducing down to small number multiplied by 10. Scientific notation is very useful to write a really large or really small number. For example, we have another number. For example, we have number 0.00. This number is small but not 0. We can write it as 8.6 multiplied by 10 raised to the power minus 7. Note that exponent is negative. Note that this exponent is negative. Positive exponent shows repeated multiplication and negative exponent shows repeated division. This is the difference between negative exponent and positive exponent. Positive means multiplication and negative means division. Now, zero point 0.000 multiplied by 1 by 10. We can write 1 by 10 as 10 raised to the power minus 1. So we write here as multiplied by 10 raised to the power minus 1. And 0.00086 multiplied by 10 raised to the power minus 1 multiplied by minus 1. We write here minus 1 and minus 1, and this is equal to minus 2. By exponent formula we write it as minus 2. 0.00086 multiplied by 10 raised to the power minus 3, 10 raised to the power minus 4, and 0.86 multiplied by 10 raised to the power minus 5. 0.86 multiplied by 10 raised to the power minus 6, and 8.6 multiplied by 10 raised to the power minus 7. This exponent shows you the nature of original number. Positive means you deal with really big number and negative means really small number. In original form, it is very difficult to say that which is greater, bigger or which is small, but scientific notation solves this problem very easily.